When you get into Scala, you learn about option as a better way of handling null, but handling null is just the beginning. Hey, Vlad here from devinside.com. Welcome to another video. In this one, we're going to talk about subtle things that fall through the cracks when discussing options. This video is not exactly a tutorial about option, but we're going to run through a very quick basic example so that everyone is on the same page. This video is both useful for beginners and advanced Scala users, and the goal of it is not to show you some magic trick or some hidden method on the option in the Scala Standard library. No. We're talking about something way more fundamental. In fact, since I started this channel almost 5 years ago, I covered pretty much every corner of the language. However, most of the things are sort of hidden inside of very long playlists, which contain very long videos. And so I decided to kind of revive some of the topics in a more short form. Obviously not as short as YouTube Shorts. Let's get started right after the message from our sponsors, which is you or people like you. We're currently on the road to 500 patrons, which help me pay for an editor. Instead of spending time editing videos, I can use this time to hang out with you during live streams or even mentorship style meetings. Huge shout out to everyone who's already supporting this channel, especially Fred Albu and Johan, who are my highest tier patrons. Thank you. Let's run through a super trivial example. As in most of my videos, I'm actually using Ubuntu 20.04 instead of WSL, and I'm using Windows shortcuts for Windows Virtual Desktop features, so I can jump to Windows like this and back to Ubuntu like this. So I'm currently in my dev directory, which is not empty as in most of my videos. I have the option 3 playground, which is using Scala 3, and I'm going to show it to you a little bit later. So I'm going to use one of my generated templates to create a project, and this one I'm going to call option-playground whenever it loads. Option-playground. I can't type today. All right, so let's go in there, and we're going to start Visual Studio Code, and I'm going to go into the main file, which is already open. Very convenient. I'm going to wait for Metals to wake up. While it loads, we're actually going to go over here, and we're going to say val first option like this, and it's going to be some hello like this, and I'm going to copy the line, and I'm going to do second option over here, option like this, and this is going to be world, and the third option is going to be calculated. Okay, so we're going to have a full comprehension over here, and we're going to yield a string. So we're going to use string interpolation for A and B. And where do these come from? Well, the A comes from the first option. We're also going to map it to reverse because I need an example of exploding whenever it's going to be null, reverse like this, and we're going to do B, which is going to come out from the second option like this. Okay, so in the end, we're just going to go and we're going to do a print line third option like this. All right, so let's see how Metals is doing. It looks like it's still a little bit better. There is something going wrong. Let's go check, and I have a hunch already what is happening. Yeah, it's exactly what I thought would happen. Let's just restart Bloop. I actually have an alias for Bloop like this. And we're going to go over here. I'm going to connect to the build server. While it does that, I'm sure it's going to fix the issue. I'm going to start SBT real quick. There we go. Create a little bit more space. Let's also create space over here. Save this file. All right, this time it looks like it's compiling, so it should be fine. Cool. So it compiled, and we actually can also insert the type over here. And why? Okay, over here as well, and over here as well, and there we go. Okay, so now let's run this super tiny program. And there we go. It should be hello world with hello reversed and world reversed as well. Now, if you've never seen option before, then this might be too much, but Scala has been around for over 10 years at this point, so I'm sure that most people are familiar with options. Here's the TLDR. Option is just an ADT, and there are two forms of it, which means there are two ways to construct it. One is a case class called sum, and by the way, the parameter over here is called value. Okay, and the other option is, well, the other way to construct it is by using none. Okay, so as soon as one of these is a none, then the entire computation is going to be none. I'm actually realizing right now that the inferred type was not option as I thought it would be. I actually wanted to have an option over here like this. Okay, so as soon as one of them is none, well, in fact, maybe at this point I should actually do hello over here so that we see that it still works even with the type annotation. Okay, so as soon as one of them is none, the entire computation is going to be none. Same thing over here, none, the entire computation is going to be none. And obviously, when both of them are none, then the entire computation is going to be none as well. Let's revert that. Well, No, too much. There we go. Hello. Now, at the end of the day, this gorgeous code desugars to something else. So we're going to go over here and we're going to do 2. Okay. So I'm going to copy this and I'm going to paste it over here and I'm going to call it 2. And instead of default comprehension, we're going to do first option map reverse. Right. And now we're going to do flat map and it's going to be the A. Okay. And inside of it, we're going to have the second option and we're going to map to reverse again. Reverse like this. And then we're going to do map over here and this is going to be B. Okay, and now we have access to both of them. We're going to construct this string with A and B. Okay, so that's exactly the same code. However, I actually want to desugar it even more. We're going to go with the third option, which is in this one. Copy this, paste it over here, find 2, replace it with a 3. Okay, so what we're going to have is first option match. And inside of this match, it's going to be none. Well, then it's going to stay none. And if it's a sum of A, well, we're going to construct another sum, and we're going to take the A, and we're going to reverse it. Okay. So now that we have this thing, we're going to match again, and inside of it, we're going to have case none. Well, still going to be none, and case sum of A, which is now reversed. We're going to do something else. Okay. So now we can do pretty much the same thing as we did above with the second option. Match. Okay. Case none. It's going to be none, and I want to close this thing so that I don't forget. And now if it's going to be a sum B, well, then we're going to do B dot reverse. Okay, and then we need to do the final map. Okay, so we need to go over here where this thing closes, and we're going to do match, and we're going to do case none. Well, still going to be none, case sum of B, and let's close this one, and now we can produce another sum, and inside of it, we're going to use our string interpolation. Okay, so this is the entire thing, and I should probably do it like this over here. Okay, so I should probably create a little bit more space. So this is now this whole thing completely sugared, completely ugly, but now if you're a complete beginner, you know what this code converts to, translates to, substitutes to. You get the idea. Okay, at this point, it's almost a tutorial. I guess I can't resist making tutorials. By the way, this code looks much better in Scala 3, and I'm going to show it by the end of the video. Now, it's all fine and dandy. If you see this for the first time, then usually you're being told that this is a better way of handling null because it makes sure that you won't forget to check for the absence of the value. In fact, option even has a special factory method called option. It's just the apply method on the option object that you can pass in something like hello world like this, okay? Or you can just pass it a null over here like this, and it will convert it to none. Okay, so this last one just was converted to none for us. There we go. This one. Let's run through a pretty much similar example. Let's actually remove this. And what we're going to do is we're going to not use option. Okay, so we're going to do a string, which is going to be a hello, small hello. And the second string is going to be world like this. And now the third string, which is a string, is going to be simply, well, I'm going to do A equals first string dot reverse, and B equals second string dot reverse, and then we're going to use string interpolation for $A, $B, and all of this code works kind of fine. Let's actually go and do print line third string, and let's actually duplicate. Oh man, this happens sometimes. Okay, so let's actually duplicate this line and put it over here. As you can see, this code compiles and it works just fine until one day one of these guys is a null. Then obviously it's going to throw an exception. I don't need to demonstrate that. It's going to happen for any of them. You get the idea. So this is the first level of understanding option. It's better than null because it makes sure that you won't forget to check for nullability. There's actually an escape hatch. You can actually call .get on any option, but the majority of the Scala community actually frowns upon this fact and wish that it didn't exist. But it kind of has to exist because of the way pattern matching is implemented. In fact, a long time ago, I made a very long video about pattern matching. You might want to check it out, and over there you'll see why this method is necessary. Maybe there's another way to implement pattern matching, but the way it's implemented both in Scala 2 and Scala 3, there is no other way. It has to exist. And obviously it throws an exception if one of these is none. There we go, none, and therefore .get throws an exception, and it's called no such element exception, obviously, right? Because option can be viewed as a list or a collection with a single element. Now, the second level of understanding is that it allows you to encode the absence and also presence of something. On the second level of understanding, we're going to talk about values. On the third level of understanding, we're going to talk about absence or presence of something else, but we're going to get to that. Let's say that you don't know that option exists, but you are a very diligent programmer. You always write your unit tests, and so you never forget to check for nulls. Let's actually go and do this over here, okay? So over here, we're going to say, so if first string is not null, okay, well, then we're going to reverse it, and otherwise, what are we going to do here? This is kind of the issue why we're here, right? So this is going to be the B, okay, like this. This is going to be the B, and this is going to be second string. Same thing over here, like this, okay? So now let's say that we actually checked for null, right? So as of right now, everything works. But what are we going to do in this case over here, right? And you kind of have three options, but none of them are good. Okay, so you can throw an exception, not type safe, therefore not good. You can kind of stay in the null world, and I'm going to show you how deep the rabbit hole goes. Also not ideal because not type safe. Or you can also use magic values, but this is not always possible because the default values don't exist for every type. And B, the default values might actually not be what you want. For now, let's just stick with null. There we go, like this and like that. Now check this out, and this fact is super, super subtle. We actually made sure that the third string cannot be null. And this fact is not immediately visible even to the most experienced developers. Okay, let me actually demonstrate this to you. So if I go and put null over here, right? Something somewhere should throw an exception, right? But it won't. And it would be really nice if we could encode this into the type system. And we actually can in Scala 3, but we're going to get to this in a second, okay? So this thing is that the toString on null doesn't throw an exception, okay? So therefore we have null over here and obviously over here as well, right? Like this, so we have two nulls, okay? It would be really, really awesome to be able to encode the fact that this string cannot be null. And with option, you kind of have this, right? You have the way to encode both the absence and the presence of none. Now, with option, you actually don't need to because you can stay in the world of option. But if you insist, you could call get and kind of denote the fact that you already handled the case of none. Let's actually jump to Scala 3 real quick. Scala 3 has this fancy explicit nulls flag that I have enabled. And therefore, over here, it's pretty much the same example, just the syntax is slightly different, but it's the same thing essentially. The first thing that we get here is that we cannot just simply go and say null over here. It's simply not going to compile because it's going to say, hey, you said that it's going to be a string, but you give it in a null, right? Found null requires string, okay? Now there's a way to explicitly encode the absence, right? So you can say, well, actually it can't be null. Okay, right, this one can be null and this one can be null. And now the compiler will hold your hand and it will say, well, not for this one. We actually forgot to reverse stuff. Okay, so over here, I actually wanted to do A, and maybe I should actually go back. Hold on, like this. Okay, so I actually wanted to do A, which is first string dot reverse, and the same thing for B, change to S, second, and there we go. And this is going to be A, and this is going to be B, like this, okay? So if you go over here and we do null over here, the compiler will warn us, okay? However, if we actually want this to be possible, we can do this, right? We can use union types like this, and now it will not allow us to just call it reverse because it's going to say, hey, it's not a string, it's a string or null, okay? And now we actually have to go there and say, okay, well, if, well, we actually don't need the braces. First string is not null, then reverse it. Otherwise, well, we're going to do null over here, okay? Same thing for B. Okay, so we're going to do yank this and like this and like this as well, like that. And this should be B, not R. There we go. Let's actually run this code as well. Let me go to the terminal and let me launch SBT, and now let's run this code, and we should see the same thing, right? So we should see null and then world in reverse. And there we go, we have this. Let's actually go over here. Let's do this thing as well. There we go. And by the way, if you actually go over here and go like this, then the compiler won't even allow us to check for null because it's going to say like, hey, values of type string and null cannot be compared with equals. Really, really awesome. Okay, so let's go back like this. Okay, now this is great, and there's a super subtle thing happening again. The type of first string is actually string on null. And therefore, if we go and try to do something like test, and we're going to do first string dot reverse, well, it's going to warn us that, well, it's not actually not a warning, it's actually a compilation issue. It's going to say, hey, this is not a string, so you cannot just go and call reverse because it can be null. But how is it possible that we're doing it here? Let me delete this real quick, like this. The type of first string is string or null. So how is it possible that over here we can actually call reverse? Well, it turns out that this is actually a methods limitation. The type of first string over here is actually already string. Let me demonstrate this to you. So if I do this, and if I do that, and I go over here, and I'm going to say something like val string equals first string, and I'm going to call string over here, right? So now you'll be able to see, okay, first string is string or null, and string is actually a string, right? So how is it possible? Well, this thing is called flow typing or flow inference, which is a very advanced feature in the Scala3 compiler. Now, I'm not a compiler guy, so I'm just guessing that this is a very advanced feature. And so the issue with it is that we can just like throw away option and go switch to Scala3 and use this thing everywhere, because it's a very complicated thing and not every language has it. And even the Scala3 compiler has limitations or bugs related to it. Let me actually show you a limitation copied straight from the docs of Scala3. So over here, when we say if second string is not null, okay, and second string equals to first string. Well, in this case, it means that the first string, well, it's also not null, okay? So we should be able to go over here and do first string dot reverse, but we can't, simply because the compiler is not advanced enough to track this. The point that I'm trying to make is that option not only is a simpler solution to the problem of flow inference, but there's also something more fundamental about it. First, let's revert all of that nonsense to go back to this, okay? So the first thing that we're going to do is we're going to talk about type safety a little bit and about a thing called cohesion. So if we go over here and we'll look at this code over here, right? Then this is basically, okay, some string comes in and some string comes out and we're going to reverse it, okay? And another way to write this would be, well, let's just take A out of the first option and we're going to match, right? And remember, we're in Scala 3. Okay, so we can do these fancy things. And so this is going to be some s, and well, I call this string over there, so let's call it string over here as well. So we're going to do, we're going to construct another sum, and we're going to do string dot reverse. Okay, so both of these ones have this string kind of like very close to them. There's no way to accidentally use the string. You only have access to the string when it's a sum. It's even more visible over here, right? But still, like if we pattern match, it's still kind of close. However, behind the scenes, what this code desugars to is this, right? So if we go over here and we're going to do A and we're going to rip it out of if first option is instance of some string, well, then please take the first option and do as instance of, okay, of some string, right? So it's safe, okay? And now that it's a sum, remember, we're forgetting about the fact that get exists. So now that it's a sum, we can actually get the value out. We can reverse the whole thing. And so I need to close the brace over here. And I need to go into the beginning and wrap this whole thing in the sum. And otherwise, we're going to stay in the none world. Okay, so it's going to be like this. Okay, and this code is much less cohesive because it's essentially where we are back to the null problem where we can forget to check for this, right? So this code still compiles and works exactly the same if I remove this part. Okay, and so if it's a null, well, if it's a none, which one did I do? The first one. Okay, so if it's a none, now it's going to throw an exception. Okay, and it's going to be none cannot be cast to class Scala sum, okay, because I forgot to check, right? So this code is less cohesive. Because of this, whether you're using pattern matching, like over here, or whether you're using map, which is even better, you don't have these issues with type safety, right? You simply have less issues with type safety if you simply use option. However, I want to talk about something way more fundamental. No matter how you encode this, with null or without, with option or without, in Scala 2 or in Scala 3, what are you going to do after you check for null, right? Because the whole goal of like checking for null is then to have some code and then to be able to run some computation. And with option, it's very, very visible, right? So if you look at this line over here, it's very, very subtle, I know. So if you look at this line over here, right, then you kind of see that, you know, because of this map, you're seeing that the only thing that you're doing here is calling this function. And so the third level of understanding of option is that option is not about deciding whether the value is absent or present. The option is the decision whether to run some computation or not. kind of like the same thing as can be said about null, right? But null can be used for many things. Option can sort of like only be used to decide whether you're going to run a computation, a reverse in our case, or not. This kind of thinking comes from category theory. Whenever category theory is explained, usually illustrations are used that are very similar to the ones from the set theory. You have some big circle with dots inside. However, there's a huge difference. In the set theory, you really care about objects or your dots inside of this circle, right? It's the biggest question, like, is my object inside of the set or not? Is it the part of the set or not? This is why, set contains like the biggest operation on set, which is also why in the Scala standard library, set extends a function from, the element type to a Boolean, right? Because this is the most important question, does my element exist? However, in category theory, we're more concerned about arrows or functions, and the object wouldn't even exist if we didn't need them to describe arrows, right? So the objects in category theory, they're sort of like a means to an end, right? It's very hard to talk about arrows if you can't say that the arrow goes from A to B. And by the way, A and B can be the same object, but that's not the point because, again, objects don't really matter that much. And so, again, this is kind of philosophical, but there is another way to look at option. It's not there to describe the absence or presence of values. It's there to describe whether the computation is going to continue or not, whether you're going to call a function or not. It's just that it's very commonly used to handle nulls. This is actually a very common pattern I noticed. The same thing happens to the reader monad, for example. You can use it for many subtly different things, but most of the time it's used for dependency injection. The same thing can be said about the cake pattern, which is frowned upon. You can do many really cool things with the cake pattern. However, most of the time it's used for the dependency injection. Well, technically, most times it's actually not used at all because, again, it's being frowned upon, but you get the idea. I want to go on a tiny tangent a little bit. I don't want to dig too much into category theory because I myself even just scratched the surface. However, if you concentrate on just using map, then you don't need to even care about the structure of option. The same as you don't need to care about the structure of null. You don't need to check for nulls. You don't need to check if it's sum or none if you concentrate on map. And if you do that, then changing your code is going to be more trivial. It's very trivial to go, if you use map and flat map to go from an option to an either, or from an either to either neck or something like this, because you simply don't care about the exact structure. All you care about is this transformation. Am I going to call the function or not? Now we're pretty much done with the video, but I promise to show you how a little bit better this pattern match is going to look like in Scala 3. So if I just grab this, unfortunately I have to use my mouse to copy stuff because of my Vim plugin. Okay, so if I go over here and paste it like somewhere there like this. Let me actually do this like that. And what is happening over there? Yeah, I forgot one curly brace. I guess it's actually the Scala compiler. It already removed a bunch of curly braces. However, in Scala 3, you can also go a little bit further, and you can also remove these params over here, right? So you can sort of like chain the match statements. So you can remove this one, and you can remove this one. Okay, it's still ugly, but I guess we can agree that it's less ugly than before. Okay, and obviously it, in the end, it's going to be third option 3 like this. So bring it over here. There we go. Okay, so this is none, and if we go over here and we do some hello, then we're going to end up with the proper thing. Okay, so it works exactly the same as before. Cool. So I highly recommend that you don't abandon option, and also that you use functions like map and flat map instead of pattern matching on it. I hope you enjoyed this video, and I see you in the next one. For now, as always, it's been Vlad from devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you wish to support tech education, please consider supporting me on Patreon or GitHub sponsors, whichever you prefer, and let's watch my videos weeks and sometimes even months before everyone else. And most importantly, take care.